all sorts. Okay, so inverse trig functions, I only want to look at arc sine, arc cosine, and arc tangent. Yes, we have three more. Arc cotangent, arc cosecant, and arc secant. I'm only interested in these and their derivatives. So when we differentiate arc sine, so arc sine prime is 1 over the square root of 1 minus x squared. Now the arc cosine, exactly the same with minus in front. And arc tangent, that is very nice, 1 plus x squared. Okay, so let's look at a couple of examples here. So let's look at y equals arc sine of 2x plus 1. I just want to caution you that you will see it normally. I prefer this notation. You will see it like this. Okay, so please be careful. This is not bringing -1 in front and subtracting 1 from the power. No, this notation is arc sine, the inverse of sine function.
How come the arctan arrow is pointing to the arc cosine?
Because I didn't have enough room.
Oh, okay. I thought that was...
No, I realized that I didn't have enough room and I didn't want to squeeze it in there. You are correct. My apologies. My apologies. So this is it. Thank you for pointing that out. Okay, so we are asked to differentiate this function. And we will differentiate. You can write with dy over dx. You can write f prime of x. You can write y prime of just y prime. Arc sine of a function is 1 over the square root of 1 minus the function squared times the inner function prime. These have to be the same. So if I have a function here, then I have a function here, but then I have to multiply by f prime, like we always do. So then I will fill it in with 2x plus 1 squared. And here, 2x plus 1, because I put the prime, I have to copy it. Yes, you can expand just for now because you get 4x squared plus 4x plus 1, and you this minus 1, so you'll simplify the 1, or just leave it as is. That's fine too. But the numerator is 2 divided by, it's up to you. I'll show both. So 1 minus 4x squared minus 4x and minus 1, and you simplify. In case you're thinking, oh, all these minuses, how can I take a square root? Well, it means that x has to be appropriate for this quantity to be positive, not even 0. So that's how we differentiate arc sine of a function. 1 over the square root of 1 minus the function squared times the function prime. Any questions on this? Any questions?
So you were saying, so
yes.
This is the final answer at the end?
Yes.
Square root of -4x squared minus 4x?
Yes.
Okay.
As long as -4x squared minus 4x is strictly greater than 0. Otherwise, the derivative doesn't exist.
Okay. But would that notation be something we add to our answer?
You don't have to. It's assumed that the function exists. They're giving us the function. They're asking us to find the derivative. But it's a very good question. You're right.
All right. Thank you.
Thank you. So we have y equals inverse cosine applied to sine inverse of t. I would have written it as arc cosine of arc sine t. This is the same. This is the inverse of cosine, and this is the inverse of sine. You can always replace this. If this is better for you and it's easier for you to remember what to do, you can. So this is the outer function, and this is the inner. Okay, I'm hoping that you understand that this is not arc cosine by itself multiplied by arc sine. There is no function without an argument. So this is the argument of arc cosine. So this is the inner function of the outer, or outer of the inner, I should say better. Okay, so when I differentiate, I have to differentiate the outer function first. And I know how to differentiate arc cosine. Is 1 over, with minus in front, 1 over the square root of 1 minus this, whatever that is, squared, and times whatever this is, prime. And now I will uncover and say, okay, let me see what's in there. Oh, it's arc sine, fine. Arc sine t. And now I have, since I wrote this, I have to write arc sine t and now continue. So minus in front 1 over the square root of 1 minus arc sine t squared. Careful not to put the square on t or something else. So that's why this, if you keep it as sine inverse, you have to have it in parentheses and the squared has to be outside. And don't say that this is negative 1 times 2. So be very careful with these functions. Times arc sine t prime, which I know is 1 over the square root of 1 minus t squared. Careful with these functions, very easy to get confused. Do you think we need another? Yeah, maybe with the arctangent. Let's look at another. Any questions so far? Any questions?
So for this problem, this is where we ended?
Yes. There is
Okay.
nothing else we can do. So this is, yes, thank you so much. This is the end. Is this okay? Any questions? Any questions? Okay, let's look at one more here. Like y equals arc tangent of x squared. So we want y prime. Can anyone get this started for us?
I can try.
Please do.
So it would be
I'll help you.
the derivative of arctan, which would be 1 over 1 plus x, well, yeah, the blank square
Something squared, right?
times the derivative of
whatever prime. Excellent. Now, x squared, and let's simplify. Let's differentiate this, and it's at the top.
2x.
Excellent. Now the denominator is 1 plus.
To the 4.
That's it. Done. Any questions? Any questions? Do you think we got the idea with these three functions? I'm happy with these three. Arcsine, arccosine, and arctangent. Do you think we need more examples with these three inverse functions?
Will we need the other three?
No. I will not ask you, and if I do, I will give you the formula. I'm testing. Yes, go ahead. Sorry.
Please, what was the answer for the very first example?
You mean this one?
Yes.
Do you have a question or?
No, I just want to know what the final answer was.
Yeah, so you can
Okay.
keep it as is, but you have to write 2 at the top though. So you can write 2 over the square root of this as is, or 2 over negative 4x squared minus 4x. Either one.
Okay.
Is that okay?
Yeah, that's fine.
Perfect. Okay, moving on. Derivatives now of log functions. Derivatives of log functions. I promise no more functions after this. Done with functions. Done with functions. Promise. After log, we're done. No more new functions. Okay. So first of all, let's look at natural log. Natural log x prime, the formula is 1 over x. Of course, natural log of a function prime. Can anyone have a wild guess here? What do you think?
1 over x times,
You mean f? Yep.
or 1 over f times the function prime.
That's it. Done. Perfect. Okay, so let's practice this, and then we'll go back and discuss other bases. Okay. Not E, so we know that this is base E. Okay. So let's say g of x equals natural log of x times the square root of x squared minus 1. Anyone would like to try? It's okay. I'll help you. It's okay if you're wrong.
Would that be 1 over
Whatever, yes, times what?
whatever?
Exactly. If you understand that, then 90% of the job is done. Good. Since I put this symbol here, I have to write it as is first. This stays as is. And now let's see what we come up with. And since it's the product rule, I have to have 2 terms. What is the first piece?
1 times square root x squared.
Excellent. What is the second piece? So of course x has to stay.
One over 2 square root of x squared minus 1.
Excellent. Times times
2x.
Times 2x. Very good. You can put it here or at the top. Since, of course, I ran out of room. No one is surprised by that. Okay, now I will simplify by 2. Find the least common denominator, which there is only 1, and simplify it as much as I can.
Where did the 2x come from?
So
Oh, was that the x squared?
the square root of a function prime is 1 over 2, the square root of the function, times the function prime. So x squared minus 1 prime is 2x. This piece is 2x.
All right.
And I can put it here at the top. I would have put it next to it, but I ran out of room, of course. So 1 over x, the square root of x squared minus 1. What is the least common denominator? Well, there is only 1, so I know you're going to say the square root of x squared minus 1. So this top will be plus x squared. There is no discussion there. But what about here? Because I need to multiply, let me use a different color. I need to multiply this by the denominator, the square root of x squared minus 1. So what do I get?
X squared minus 1.
Excellent. I will multiply these two. So I have 2x squared minus 1 over x, quantity, x squared minus 1. Do not multiply the factors in the denominator. Actually, we want them factored. So you don't have to do this because you don't have to, because we cannot further simplify, but do not distribute. Definitely do not distribute in there. Good. Any questions?
So
Yes?
there's the 1 over x thing on the left. What's its relation to the thing on the right? Right, directly to the right of it?
This one?
Yeah.
It's this piece. Natural
Yeah,
log.
but what's its relation to the thing directly to the right of it?
It's multiplied. So we are using this. 1 over the function times the function prime. This is our function. So it's 1 over it times it prime. But when I uncover and I look carefully, I'll say, oh, it's a product. So I have to use the product rule. First function prime is 1 times the second plus the first times the second prime. So this is a product here. If there is no symbol, it's always product. So then we found the LCD, and then we multiplied, we got x squared minus 1 plus x squared. Because I simplified the 2, and x times x will be x squared. So this is multiplication. If there is no symbol, it's multiplication. Otherwise, I have to write addition, subtraction, or division. So if there is nothing, it's product. So let me put it so it's clear. So I multiplied these two, and I copied x, and when I multiply the square root by the square root under certain conditions, we assume that they are satisfied. Otherwise, I have to write the absolute value. I mean, the square root of x times the square root of x is the square root of x squared, which is the absolute value of x. But we're assuming in this situation that everything is legit. So I don't need to put the absolute value here. So I multiply these two, I got this, I got x, and then I have 2x squared minus 1.
Are the things at the bottom saying where the holes are?
You mean here? Say that again, please.
Beneath the answer.
Yes, I said do not distribute, and I said you could factor this into x minus 1 times x plus 1 because it's a difference of squares. But there is no need to do that because we cannot further simplify. I cannot factor this, and they will not be common factors. So this is not needed. But I was saying just definitely do not distribute x. But this is not required. Is that better?
Yeah, I think so.
Yeah, so I was just saying we want all denominators fully factored. But in this case, there is no reason why I would continue and rewrite this like this because the numerator is not factorable. If I have, I don't know, x plus 1 in the numerator, then I have to change this because I will be able to simplify. But I don't have x plus 1 or x minus 1 at the top. So there is no need to do that. Okay, let's look at another. Something like f of x equals x over 1 plus natural log x. Let's see how we simplify, how we determine the derivative of this. So which rule applies here?
Quotient rule.
Perfect, excellent. we should always start with the denominator because I don't have to do anything to it. Who would like to help? It's okay. If you're wrong, no problem.
I could start.
Yes, go ahead, please. Louis, thank you.
At the top is going to be derivative of the top function, which would just be 1 in
Good.
this case.
Yes, so I copy the denominator, minus. I have to have the top now, and I have to be careful what I write for the derivative of the denominator. What do I get?
That one would be 1 over x.
That's it. Times x prime, but that's 1. So I will simplify these two, and I have 1 minus 1. So final answer, natural log x over 1 plus natural log x squared. And this is it. Okay, so I would like to go back to other bases, not natural log e, but log base a of x. So let me refresh our memory. When we have e to x prime, we get e to x. But I should write times natural log e. I don't because it's 1. If I have a to x, well, it's a to x, but times natural log a because this is not 1. Now, when we differentiate natural log x, we get 1 over x. I should get in the denominator times natural log e. Well, the reason I don't have it is because it's 1. Well, so then natural log a, sorry, log base a of x, I'll change that. What do you think a wild guess will be? You guessed it. It's natural log a. 1 over x, natural log a. Of course, if it's a function, log base a of f prime. Anyone? A wild guess? Which is not really a wild guess at all. What do you expect? How will you differentiate log base a of a function?
Use the chain rule.
Exactly. So what do you
One-
think?
1 over a function, ln a, times that function prime.
That's it. That's it. So let's look at an example. Let's say f of x equals log base 5 of x e to the x. Anyone would like to give it a shot? It's okay if you're wrong.
Would it be 1 over x to the ex times log, natural log of 5?
So you gave me this, you gave me this, you gave me this.
Oh, so x times e to the x?
Prime.
Yeah.
So let's write the product. It's the product rule. I have to have two terms. Two quantities. They're not really terms, but because they're not polynomials, but two quantities.
Would it be e to the x plus e to to the x times x.
So yes, so it's x e to the x. Very good.